When I was 4, my brother and I had this idea to play a game called baseball golf. So you had a tennis ball and a baseball bat, and the goal was to hit the tennis ball as far as you could with the bat. So since my brother was 6 and I was only 4, he decided that he was more capable of showing me how to do it and starting us off. So he goes to hit the ball and he lines up and he swings as hard as he can. But instead of hitting the ball, he hits me. He hits me right in the middle of the forehead, and I'm bleeding, and it was really chaotic, and I was in a lot of pain, and I was panicking, and we get to the hospital. They've already numbed me, and they're going to stitch me up, and the doctor puts one in. And I was panicking that this was really going to hurt. And then he tells me, Taylor, I've already put one stitch in. So then me, being kind of fascinated by doctors, ask if I can watch. So they pull this mirror down, and I watch him stitch me up. And I was just really amazed at how quickly he did it and how doctors are so willing to help. But I was also fascinated after I left the hospital when my body and my skin had healed itself back together. So this spurred me to be interested in medicine. So throughout my education, I've worked really hard to learn as much as I can about medicine and doctors and how they all intertwine. So I've learned about diabetes and other diseases, the body systems and how they all work together, medical interventions and different types of doctors. And most recently, I've learned about pain and how your body receives the signal of pain and responds to it. And also how your body can fix itself anytime something goes wrong. So when something goes wrong, you're differing from homeostasis. Homeostasis is when your body is normal, to put it simply. Your heart rate is normal, your blood pressure is considered normal, your temperature is not too high, it's not too low, all of your organs are functioning properly, stuff like that, when your body is just normal and you feel fine. So that's homeostasis. An example of when homeostasis differs is, say you eat a big piece of chocolate cake. So a lot of sugar has entered your bloodstream, and now your body is going to work to return your body back to that normal blood sugar level. So your pancreas secretes insulin, which then tells your cells to take in sugar, lowering your blood sugar level and returning you to homeostasis. Your body is always doing similar tasks to return different things. Say you're really hot, so then you sweat so that you'll cool down, and your body is working to return yourself to a cooler temperature. When you're cold, you shiver so that your muscles are preserving energy and hopefully warm you up a little bit, and so you don't die of hypothermia. So your body's always working to do similar processes to fix itself. Another example, which is most fascinating, is pain. So say you fall off a cliff. You probably, this cliff fall resulted in a big gash on your arm. So you're bleeding, there could possibly be a fracture, and so you're feeling a lot of pain. This pain is interpreted by your nervous system. The first step for it to get to your nervous system is the sensory neurons, which are all up your arms and all throughout your body underneath your skin so that you can feel sensations such as touch, heat, etc. So your sensory neurons are feeling this pain. They're sending the signal up your arm all the way up here to your spine, which serves as the middleman between your sensory neurons and your brain. So your spine, your spinal column more specifically, sends it up to your brain, and it is then processed by different parts of your brain, such as the parietal lobe is where your sensory information is perceived, but there's also the thalamus, which interprets the emotional connection to pain, which is why you cry when you feel pain. So your brain is working to interpret what part of you is hurt, so your arm, what has caused your pain, your fall, and what is wrong. So there's a gash. It's also working to fix that. So it sends extra blood cells to your arm so that platelets can help clot so you don't bleed out. It's also telling your immune system to send cells to fight off any antigens or pathogenic material that could have gotten in that can cause an infection. So your body's working, all of these systems, your immune, cardiovascular, nervous, respiratory, which is working to slow your breathing and keep you calm, are all working together to keep you from basically going into paralysis and dying. So it's all working together to keep you healthy and make it so you can go get to the hospital and get treatment. But for something more drastic, such as if you really did fall off a cliff and a lot of different limbs are injured, maybe you've broken a leg, you have internal bleeding, this pain can be stopped by a neurotransmitter that we call endorphins. So these endorphins go to your neurons, more specifically the sensory neurons, and they just smother the synapse, which is the gap between two neurons where the signal jumps. So your pain signal is traveling down one neuron, and then it gets to the synapse, which is the space in between, and then it jumps. The endorphins smother that synapse so that the pain signal can't jump, which then causes it so that your brain doesn't detect that you are in pain, so you can have time to get away and go get help. And there you can save yourself. So your body is always working to keep you alive. It's working as one big machine that is working to keep you safe and keep you alive. And it's so in sync that sometimes you don't even need a doctor. So when you have a scab, you don't even need to go to the doctor for that, because your brain and your body and your heart, all of these organs are working together to keep you alive and keep you safe. And it's just amazing how your body works together to keep you alive.